Why does nature choose fractals? What matters when we choose something to buy? If the price is too high, we hesitate. If two options cost the same, we often choose the more attractive or better performing one. People naturally want better results with less money and effort. In economics, this is called achieving maximum benefit at minimum cost. Simply put, it means using less to gain more. But is this way of thinking unique to humans? Surprisingly, nature makes similar choices. Nature creates the most efficient structures while using as little material and energy as possible. And one pattern that appears again and again in this process is a fractal. Think of a tree. To survive, a tree must absorb sunlight and carry out photosynthesis. So, having more leaves is an advantage. But what if branches and leaves grew in no particular pattern? The upper leaves would block the lower ones from sunlight. Then the branches and leaves the tree worked to grow would become useless. That is why trees use fractal structures. By repeating branches in a regular pattern, they can spread leaves across a wide space using less material. This allows them to receive more sunlight and improve the efficiency of photosynthesis. It is as if nature chose the most economical method on its own. Ferns are similar. If we look closely at a fern leaf, a small leaf appears within a larger one, and a similar shape repeats within the smaller leaf. Why is it shaped this way? If a plant had to store every detail of a complex shape in its genes, it would require an enormous amount of information. But with a fractal structure, complex forms can be created from simple rules. Nature creates efficient structures with very little information. Lightning is another representative example of a fractal structure. It does not travel straight from the sky to the ground. It branches like a tree as it moves. Why is this? Because air is an insulator that does not conduct electricity well. Lightning moves by finding the path where electricity can flow most easily through the air. But because moisture and ions in the air are unevenly distributed, it keeps seeking the direction of least resistance and branches as it moves. As a result, a complex fractal pattern appears. Scientists explain this phenomenon through diffusion-limited aggregation. Randomly moving particles stick together, forming branching structures. Snowflakes, mineral crystals, blood vessels, and river networks are all formed in this way. Simple rules repeat to create forms of remarkable complexity and beauty. Nature constantly seeks efficiency. It creates the most stable and effective structures with the least material and energy. As a result, fractal structures appear. Could the very small and the very large resemble each other? What if the invisible world of atoms and the vast universe shared similar structures? Nature has a layered structure. Tiny atoms come together to form matter. Matter gathers to create living things and planets. Countless stars and planets then form galaxies. What is remarkable is that the very small world and the vast universe often show similar patterns. In the end, everything in nature is connected, from the smallest to the largest. Even a single tree branch nearby may hold principles similar to the order of the universe.